and a sagittal suture here, just behind it. So we don't see a metopic suture here in this particular adult skull. We see a full frontal bone here. And behind that coronal suture, we see a left and a right parietal bone. And we see the suture in between, not completely fused. So this is, the coronal suture is a little bit more fusion, so not a particularly old individual at the time of death. The lambdoidal suture we see back here. If you'll notice, that there are some, in the suture areas, some of the bones are actually disarticulated from the suture line. And there are two ways of looking at this. There was actually an anatomist named Wormian, right? Dr. Prideaux taught me this one. And Wormian described those bones, but there's some anatomists that talk about them from the perspective that they're Wormian because they get disassociated from the suture line by the suture line itself and separate these tiny bones from the suture line. So these are sometimes referred to as Wormian bones along the suture line. If we look at the lateral aspect of the skull, most of you don't have some of these structures like this little hook here or this spring here. We'll kind of take that off for the moment. But we have a temporal bone over here with its with the mastoid process and the zygomatic process of the temporal bone. Here's the articular tubercle over here, and this ridge in here is the articular eminence just in front of this depression. That is the glenoid fossa, or the mandibular fossa area. Here is a opening in the side of the skull. This is the external acoustic opening over here. Let's see, maybe the back. It's really over there. And then we still have on this skull the presence of a styloid process. These many times break off these skulls after a short period of time. So styloid processes. So these are all temporal bone portions. I was talking to you this morning that we have, in particular, in this area, we've got a opening here. I'll point it out and then talk about the bones that are surrounding it. This opening here, adjacent to the medial side of the glenoid fossa, this is referred to as the petrotympanic fissure. And it is called petrotympanic fissure because this portion of the temporal bone is petrous portion, but this portion of the temporal bone around the external acoustic meatus is tympanic portion. So those are the two aspects of the temporal bone that create that fissure. If we come over in front of the temporal bone, we have the sphenoid bone. This is the greater wing of the sphenoid bone. And we also have the frontal bone. This line here is created by cutting the calivary off the top of the skull. And then we have the parietal bone. So there's a point here, just adjacent to this little screw in the side of the skull. There's the frontal bone, there's the greater wing of the sphenoid bone, there's the anterior superior aspect of the temporal squama here, and there's the parietal bone. That has this they should talk about when they're talking about facial growth and development in cephalometric radiographs. You can see this area or mark this area on the radiograph. That's called the pterion. That's the point where these four bones come in contact with one another or articulate with one another. So P-T-E-R-I-O-N, pterion. We come back here to where the temporal bone articulates along this suture. That's called the squamosal suture here, and then it comes over to engage this lateral portion of the lambdoidal suture over here. If we come forward from the temporal bone, we have from this articular tubercle, then we have this zygomatic process in the temporal bone, and we have the zygoma. Okay? And the zygoma articulates with its temporal process of the zygoma with the zygomatic process of the temporal bone. And then there's a space here deep to that arch, deep to that zygomatic arch. And what goes through there? You probably know this just from seeing photographs or illustrations in textbooks. What do you think goes through underneath this arch?
A muscle.
Okay, we're going to have a lot of work with this class, I can see already. There is a muscle that sits out here along over the temporal bone, the parietal bone called the temporalis, that comes down to attach to the mandible, that goes deep to this arch. If for some reason this arch is fractured from the outside, it will dig into the temporal bone and to the temporalis muscle, and the temporalis muscle will go into spasm and you won't be able to open your jaw. So sometimes that happens on weekends. Somebody, might have happened this weekend in relation to the Super Bowl. There could have been some bad interactions there. There were definitely bad interactions on the field. But, or let's say a baseball bat, something large and solid being thrown into the side of someone's head could easily fracture that zygomatic arch. In the center of this zygoma are usually one or two foramen. These are called zygomaticofacial foramen. These are branches of the zygomatic branch of the maxillary division that come through the zygoma on its lateral side. In the back of the zygoma, it's kind of over. I don't really want you drawing on the skull, so please don't do that, but whoever had this one didn't listen. There's an opening here behind the zygomatic bone. This is the frontal process of the zygomatic bone, and this is a zygomatico-temporal foramen back here. As we come forward, we come into the lower aspect of the frontal bone, and we see there are actually some openings here. Here's one here that's completely surrounded by bone. Here's a notch here, but not an opening. So this is the superior orbital rim. It's a little bulbous in this particular skull. We see a little bit of a notch in the glabellar region. So this is more than likely a male skull. Males will have bulbous superciliary arches, and they will have this bulge over this smooth area or glabellar region of the skull. And they come down over the top of the frontal process of the maxilla and these two bones in the center, which are called the nasal bones. And in the front of the nasal bones, as we were talking about today, with one of these branches of the interethmoidal branch of the nasociliary, there are openings that transmit a nerve called the external nasal to the bridge of the nose. But these openings here, this one is completely surrounded by bone, would be considered to be a supraorbital foramen. This notch here is really doing a similar thing, but we would call this a supraorbital notch. So this is something that isn't consistent from one skull to another. But what's coming around this area is, or through this area, is going to be the supraorbital branch that is coming back into the frontal portion of the ophthalmic division of the trigeminal. So we come from the zygoma and we come to this bone in the front on each side of the nasal aperture. These are maxillas, and the maxillas have a have a foramen here that goes into the orbit, then into a canal. This is the infraorbital foramen and inferior or infraorbital canal, or sometimes referred to as the anterior portion of the inferior orbital fissure. This is the nasal aperture in here, and I don't know how this is. Does this show up? This bone over here on the lateral side of the nasal zone. This is the inferior concha or inferior turbinate bone, and there's one on each side. There's a pair of these bones. If we go up a little bit higher in the back, this bony plate in the midline is the bony portion of the nasal septum. It consists of a lower portion here, that's the vomer, and an upper portion that's the perpendicular plate of the ethmoid. Okay, and then alongside of that is another concha called the middle concha, and it's a little bit hard to see the superior concha. Let's see on this skull. This is kind of an interesting skull. Because it literally totally disarticulates. So here we see a portion, really what's left of the vomer and a piece of the perpendicular plate. If we go in here, we see a inferior concha, a middle concha, and a superior concha. We also see a sphenoid sinus in the back of this area, the nasal chamber. So the reason those two bones are that far back is that there's a cartilage that comes in from the proboscis area of the nose and comes in down the center and articulates with those. That's the nasal septal cartilage. So the nasal septal cartilage goes a good way into the nose to come in contact with the vomer and the perpendicular plate. When there are usually septal deviations, they're caused by banging that anterior aspect of the nose, probably forcing that cartilage into the bones and causing the bones to be disarticulated to one side or the other. Okay, so that's kind of something that sometimes you see if you happen to have a rotation, an internship rotation in a hospital. When you get out of here, you may see that in relationship to facial trauma. So these are people that will many times come into the emergency room, especially on weekends. Okay, so let's see. This aspect here in the midline, a lot of the skulls you have too will have a variety of amount of dentition still in place. Some of these skulls are probably, I'm thinking, probably 40 years old. Okay. Yes.
We can't see anything.
How's that?
Too bright.
Is it too bright?
Yeah.
Is that any better?
Yes.
Yes.
So what we see here is the spine sticking out. This would be between the two central incisors, maxillary central incisors. This is called the anterior nasal spine. Okay, will usually show up even on periapical radiographs that you're taking as a very radial opaque region above the central incisors. Too much fusion. Talk about that later. So the infraorbital foramens in the maxilla, here and here. These processes going up from the maxilla at the highest point articulate with the labellar end of the frontal bone and the lateral borders of the nasal bones. If we come down here, we have the mandible. Okay, looking at it from from the side, it's a little bit more definitive. This is the area of the body.